Here we go. Thank you. A brief overview of our schedule tonight. We're going to go through some brief introductions and public relations stuff, which I'm doing now. Then we'll have the day in the life of a project engineer in the optical manufacturing industry presented by Dr. Estephany Santiago, followed by a brief Q&A and a exit poll. There we go. So a little bit about the American Chemical Society for anybody who doesn't know. It is the world's largest scientific community, and its members have access to career development and networking, member groups and communities, conferences and events, as well as funding and awards. So lots of exciting stuff. If you're not an ACS member, you are encouraged to become one today. Are we missing? There it is. Okay. So a little bit about the career development. We have the CNEN jobs database, as well as free career consulting, career pathways workshops, and the Chem IDP, which is the individual development plan. That one, you can actually track your career through the years and do a ton of career development stuff with the ACS. If you're interested in the free career consulting, they do offer the free office hours. Let's see, there we go. On the first Thursday of every month from 12 to 1:30 p.m. Eastern Time. The ACS also offers member groups and communities, which are inclusive groups and communities for all. This includes the Women's Chemists Committee, Minority Affairs Committee, Younger Chemists Committee, that's us, and Chem Clubs. That is just scratching the surface of it. There are technical divisions, so many more committees. You are definitely encouraged to look through all of those. ACS also offers a ton of conferences and events. There are the national meetings. We have San Francisco coming up in the fall this year, as well as New Orleans in spring of next year. Those are a ton of fun, lots of networking opportunities. If you're interested in that, definitely check them out. There are also regional meetings and the green chemistry conferences. A little bit about the YCC. We are younger leaders transforming the world through chemistry. So that means that we advocate for, develop, and support rising chemists like you. If you're interested in getting involved, you can attend YCC events at ACS national meetings. We are going to be having our 50th anniversary in New Orleans next spring. So we're going to have a ton of events for younger chemists like you. You can join or start your own local section YCC and apply for YCC sponsored awards. So as you can see, we offer a lot of fun events. We've had brewery tours, cidery tours, lab tours. There's a mentorship program, and we've done a bunch of professional development panels. You can find us on social media, either by scanning the QR code with your phone. I'll leave this up for a second so you can, or looking us up on just about any social media that you can think of. We also recently started a YouTube channel where we are uploading the recordings of the Day in the Life events. We've won several awards for the Day in the Life series. We've won Best Activity or Program Stimulating Member Involvement with the Eastern US YCC Partnership, which was formed at the start of COVID. Just a bunch of YCCs came together to offer programming like this. And last year, we won the Outstanding Continuing Public Relations or Communications Program of a local section. If you have questions, please ask them in the chat during the presentation, or feel free to unmute and ask during the Q&A after the presentation. With that, I will introduce our speaker and also give you guys some links to everything that I was talking about during my introduction. Our speaker today is Dr. Estephany Santiago. She is a project engineer in the optical manufacturing industry for Carl Zeiss Vision Care. She earned her PhD in chemical science from the National Technological Institute of Mexico, the Tijuana campus. And she earned her master's degree also from the same institution, where she worked on the synthesis and modification of nanoparticles made from biopolymers for controlled drug release. Before she joined Carl Zeiss, she also worked as a professor at, I believe, the Tijuana Campus University, as well as for a teacher for middle and high school. With that, I will pass it over to Dr. Santiago.
Hi, everyone. Nice to see you all here. Today, I will do this presentation, and let me share my screen. Okay. Okay, so today I'm going to talk to you about what is the day in the life of a project engineer in the optical manufacturing industry. I work for Zeiss Vision Care. Zeiss brand is a huge brand worldwide known for doing microscopes, cameras, and also microchips. And we also do vision care products, which includes vision glasses. But before I start moving on about the industry, what we do here, I'm going to start talking about myself so you can understand how you can become to a project engineer, even if you're not looking to become a project engineer. Well, I am from Tuxtla Gutiérrez, Chiapas, Mexico, which is Chiapas is the southern state of Mexico. We are next to Guatemala. Just to you take a better look in the map. Here in the bottom is Chiapas, right here is next to Guatemala, and Tuxtla Gutiérrez is the capital of the state, and we are about near to the center of the state. We have plenty beauty and beautiful landscapes. We have the Cañón of the Sumidero, which is amazing and it's beautiful there. The weather is warm the whole year, and it's a beautiful place to grow up and to live. I did my bachelor's degree in chemical engineering in the National Technological Institute of Mexico, Campus Tuxtla Gutiérrez. I graduated in 2008. And then I moved to Tijuana, which I wish I pulled the map. I totally forgot. Tijuana is in the state of Baja California. Tijuana is right next to San Diego. So you can have a better understanding where we are. And I did my master's degree in 2016, and my dissertation was about biomimetic produced nanopolymeric beads for controlled drug release. It was a good experience, but after this, I was not sure if I wanted to continue to a master's degree, to a PhD. I'm sure that a few of you probably felt that. So I moved back to Chiapas, where I work as a teacher for high school, middle school, and also I was a part-time professor in the Tuxtla Gutiérrez campus for the National Technological Institute of Mexico. And then I realized, and also my students helped me to realize that I wanted to study and pursue a PhD. So I moved back to Tijuana to continue my preparation. So I did my PhD in magnetic nanoparticles, and the dissertation was design of magnetic nanoparticles to improve reclaimed water quality. I work a lot on the synthesis, modification, and characterization of nanomaterials, with highlight in magnetic nanoparticles of iron oxide. It was amazing. I love everything I did there. I share some of the results in a couple ACA's national meetings. So I encourage you to pursue, to go to these national meetings. It's a lot of fun, and you meet a lot of people for sure. So what I like, what I do in a usual day or in my free time, my spare time, I love to coloring, and I want to learn how to painting in a more professional way. So I go crazy about all the art and coloring stuff. I like to read books. I wish I had more time to read books, but I'm trying to build a bigger collection of books, novels, science fiction, a little bit of everything. I like cooking, especially cooking for other people more than me. And I used to do a lot of rock climbing and yoga. I'm waiting to go back on track to it. And talking about my research, what I did in my master's and my PhD, I work a lot with biopolymers and nanomaterials. I did super hydrophobic surfaces and water treatment and reuse of water, materials characterization, and of course, iron oxide superparamagnetic nanoparticles, the synthesis, modification, characterization, and more. like I say, I had a previous job before my current job. I worked for the health department of the state of Chiapas as epidemiology assistant. It was more like an internship, but I learned a lot during the year that I was working there. I also, like I say, I was a middle school and high school teacher and a university lecturer. It was a great experience, and I have so much respect for our teachers out there, and I don't see how I can fit there so far anymore. Then I started to work for Zeiss. Zeiss is a multinational company, and it's a national leading technology enterprise and operates on the fields of the optics and optoelectronics. If you work in a lab, you probably see our products in many cameras or microscopes. For its customers, Zeiss develops and distributes highly innovative solutions for industrial technology, quality assurance, microscopy solution in the life sciences. Also, we do lithography optics, and which is used in the chip industry to manufacture semiconductor components. We also are active in almost 50 countries around the world. We have 30 production sites, 60 sales and service companies, 27 research and development facilities, and Zeiss invests 13% of its revenue in research and development, which is good for a company development. Zeiss Vision Care is one of the world's leading manufacturers of eyeglasses and ophthalmics instruments. The unit is allocated in the consumer market segment because Zeiss is divided in some segments. One of them is the consumers market, and inside the consumers markets, we have the vision care products. And we develop and produce and offer entire eyeglasses value chains that distribute globally under the Zeiss brand. And I have working as a project engineer for Zeiss Vision Care at the Technology and Innovation Department here in Tijuana, Mexico, since January 22, which is last year. So I want to talk to you about what a project engineer does. A project engineer is a professional who is responsible for all the technical and engineering aspects of their assigned projects. They plan, schedule, predict, and manage all the technical tasks of their assigned project to assure accuracy, proper resources, and quality from start to finish. A few of the responsibilities of a project engineer is to prepare, coordinate, schedule, monitor, and assign engineering projects. Also, we monitor compliance, we monitor practices, quality policies, we perform standard specifications, and we perform overall quality control over the whole work, since the budget, the personal performance, the regulatory project status, and also assign responsibilities and mentor the project team. We cooperate and communicate effectively with the project manager, which is different than the project engineer, and other project participants. We review and check all the deliverables and initiate appropriate corrective actions. Sounds like we do a little bit of everything, and yes, we do. So what are my main responsibilities as a project engineer for the optical manufacturing industry? Well, my responsibilities include to evaluate the feasibility of new processes and products and or their changes. We also do qualification of new processes, products, or the changes. We validate them, and we make sure that we do the handover or the takeover of the new processes, products, or the changes to mass production for operational readiness and inventory build. We advise and guide and assist different engineering departments in the manufacturing side for problem solving, and especially the ones that can affect or compromise the yield performance of the products. We research for new materials, components, technologies, and for current or new processes or products. I do a lot of characterization of new materials. I elaborate reports, presentations, and confidential documents with obtaining results of different stages of the advanced product quality planning, which is called the APQP research. I do research and feedback to suppliers or teammates in other Zeiss facilities around the world. So for those that are not aware of the optical glasses technologies, there are two main sources to manufacture spectacle lenses, which is plastic, also known as an organic glass, and the real glass, also known as mineral glass. Glasses plastic materials for lenses come in 4 types. They usually are polyethylene, Tribex, polycarbonate, and high index polymers. So the first one, the standard plastics lenses, we can call them, they're usually called CR39 because the plastic is made or named after the Columbia resin number 39, the 39 plastic which was produced by Columbia resin. And it's no more than polyallyl diglycol carbonate. We can see the structure here on the right. This is the most popular or the first polymer that started the industry of glasses made from plastic. Then we can make or elaborate plastic lenses using polycarbonate. Polycarbonate is a synthetic plastic first developed in the 1890s, and it's a fantastic material for optical lenses because this type of plastic can be made from a transparent source, and it can be easily molded, and also has a good impact resistance. And the formula of the polymeric change, we can see it here on the right, and we can see the main difference between the polyallyl diglycol carbonate and polycarbonate. I want to highlight that polyallyl diglycol carbonate is a monomer, a liquid monomer, and polycarbonate, we get the pellets and we mold the lenses with this. Tribex lenses are also high impact resistant, but these ones are urethane based. It's a prepolymer plastic, much like polycarbonate. Tribex and polycarbonate lenses are equally impact resistant and can be completely UV protective depending on the UV blocking you add. And then we have the high index polymers. This kind of lens, the polymer frequently contains sulfur, and these lenses have a greater refractive index thanks to the atoms of this strong element, which is result in narrower lens. Despite the smaller size of the lens, the high index lenses are heavier due to the higher density of the plastic used for manufacture them. One thing also I want to say is that CR39 lenses, they have an refractive index of 1.5, and polycarbonate has 1.59. Tribex around the same. High index polymers are higher than 1.59. What is this high index number means? The higher the high index, we make a smaller or less narrower lens, which I will talk about how thick they can be when you mold the lens. So, 1 second. How are the stock lenses and semi-finished lenses made? Well, the stock lenses or semi-finished lenses are made from plastic and are created in a casting process. Special ingredients such as improving UV absorption, which can be the UV blocking, are added to the liquid materials called monomers, and these mixtures can be poured into molds and hardened with heat when you heat it, and then the process processes to reduce residual stress. When you get a semi-finished lens, can look like thicker than we probably would think about. The thickness of the lens will depend on the base of the lens, and they can go from 1 centimeter to half an inch, or depending the curve or the lens. Then the semi-finished lenses are ready for use, and it will serve like a stock lens. Then a hard coating can be applied if requested, or additional coatings. But what happened to the lenses that we get like this big puck and they are not surfaces to be ready or used? We can is what it will call after casting lens. Well, after you get the casting lens, you will fit, etch, and cut. And I want to show you in a video that can help us to understand more of this process. 1 second. So let me know if you can see the video I will present. Second, oops. So first we calculate the order and preparation. This is in one of our facilities, laboratories facilities. We block the lens and we put the alloy on the lens to help secure the lens and help the process to moving it around. Then we generate the optical surface, and you can see the machine is cutting and
Stephanie, I'm sorry, we actually can't see it.
Oh, okay, I'm sorry. Let me share again the screen. Sorry again. Okay, I'll go back to it. So when you go to get a prescription, then you go and get the order, and the order gets prepared in one of our laboratories. Then we move to a blocking station. The blocking station will put alloy on the lens, and it will help it to move around the facilities without damage the lens. And then go to a generation and the optical surface with a machine that will cut it to the right thickness to be used in a proper lens shape. And then go to polish and washing. And after this, you can tint the lens. This is optional in many colors, or you can go to a hard coat and anti-reflectance anti-glare coating. And once this is ready, we manually inspect every single lens, and then we send them to quality control, then packaging. And once the packaging and people get it, we can cut, etch, and fit to our to the desired shape for your eyeglasses. And that pretty much it. I hope you were able to see this now. Let me go back to the presentation. Well, after we get the lens, then as you can probably figure it out so far, all these lenses are made from plastic, yes, but isn't plastic a problem nowadays with our environment? Yes, that's why Zeiss pursue a lot of sustainability goals, and Zeiss aims to achieve carbon neutrality in the way to operate by 2025. This complements the company's existing goal of switching to green power as key Zeiss worldwide by 2022. And as a part of our corporate governance, Zeiss pursuing a long-term holistic approach that defines day-to-day operations. We have 5 main sustainability goals, which are powered by employees, the environment, social engagement, integrity compliance, and products and value change. So we're pursuing a lot of sustainability in eyeglasses. How we can make this possible? Well, we started sustainability initiatives, which include resource savings, using less water, less energy, plastic goes to the production for eyeglasses, and less CO2 emission and across the entire value chain. We also are aiming for sustainable product developments. We continually scrutinize and improve our production processes. We are developing methods that allows manufacturing lenses with decreasing material input and replace also outdated production equipment. We have this also social engagement, which is acting responsibly. And one of our missions here is clear visions for everybody. We support very different local initiatives that are dedicated to this topic. So now that I talked to you about me being a project engineer and working in Zeiss and my responsibilities, I want to talk to you about the green lens strategy and what is my contribution as project engineer and technical leader for this type of projects, where the green projects includes the evaluation of new materials and technologies for the sustainability goals and development of new processes that can help company sustainability goals. I do research of new materials, components, and explore the possibility of being used for a feasibility test, which this means I go for prospective new materials and I can test them and say, oh, this has an opportunity, or this may be taken as a serious candidate to replace or to make this new product. I do a lot of chemical characterization of new materials. This is more than wanting to know how this work or why it work this way. We do this chemical characterization to be sure that it will be used to save, useful and safe to use in mass manufacturing. What I'm meaning with this, if you get a new product or a new type of monomer and you wanted to use in your current processes, they may degrade or decompose faster than the usual material, and this will damage our moldings or other machines that can use. Or they cannot be attached properly to a certain type of coating in any part of the process, and this will represent a danger or a problem not only for the process but also for personnel. We research new technologies that potentially can substitute the current ones with environmental advantages, as we can replace one technology that uses a lot of energy for a new one, or we can say, oh, maybe we can use this machine that can save water or can save energy and many other things. As a technical leader, I deliver updates. I do presentations, reports about the status of different green projects in Mexico, in the US market too. And I support fellow co-workers in the Zeiss sites, which mainly are Germany, Australia, and China. I continuously do meetings or feedbacks with cross-functional teams in Mexico and other sites, and coordinate feasibility testings and support the engineer who can be in charge to run the actual test, or it can be me doing the actual test of the product. I give feedback to suppliers, and I'm part of the meetings with new suppliers. With this, I wanted to go to my daily routine as a project engineer, especially here in Zeiss. My work schedule is 7 to 5 p.m. every work day, Monday to Friday. And I start my mornings attending meetings, especially with Germany, and respond to emails. Then I make a list of my projects and prioritize them for the day or for the week, what needs to be done for today and what needs to be done for the next week. I also plan and design experiments for the day and organize and arrange future meetings. After I'm done with this, I move to the next section of my day, which also can include attending more meetings, depending if these meetings are here in Mexico, they probably can extend to 9, 10 a.m. If I don't have more meetings, then I go to work in the lab, and I set experiments for the day, or I can go to the manufacturing site and work there, depending what stage of the project I am. And if I'm not doing work or manufacturing work, I will go to my desk and I start making some reports. There's always a report to do. So the afternoon from 12 p.m. to 5 p.m., I can move the experiments from the lab to development area in our building. We have 2 laboratories. I'm in charge of one laboratory, which is the mixing room. We call it like that because we do a lot of mixtures of resins and other experiments. And usually when I have the experiment or the resin ready, I move it to the development area when we have more machines, when we can try these formulations and more. Sometimes I just continue working on the manufacturing side, especially if we are casting or molding lenses for our testing, or if there's like a problem you need to solve in the manufacturing area. Also in the afternoon, especially around 4 to 6 p.m., sometimes we can spend more time. I attend meetings with project teams to discuss the experiment results in Mexico, and it can be China and Australia join us in the afternoon. And suggest new research route if it's necessary, or overview it with my coworkers. If I have spare time during work, I'm most likely be doing report writing or paper writing, which is company confidential papers that we do with our findings. I also do 5S in the work area and laboratory, which is pretty much maintain all the areas clean and with good order. I go and check the material that we may need to order, and I do the order for procurement to purchase the material for the laboratory. And also I can have my time for paper research or reading, and also I can attend company trainings. There are challenges and also rewards or perks working as a project engineer in the manufacturing industry. One of the challenges that I had to overcome is that it's a men-set environment, especially on the manufacturing side. Is more male engineers than women engineers. although in my area, technology and innovation, we are half and half almost, men and women. But it can be a little bit challenging dealing with the environment, with the manufacturing side. Also, this is a new field for me. It's all about polymer science. I did polymer science a little bit. We're working with biopolymers. My work is now fully polymer science, which I had to dig more into my knowledge of that. It is challenging, but at the same time, it can be a good challenge. I do a lot of engineering work. Yes, I graduated as a chemical engineer, but I never went to an engineering site and work as an engineer, because I went to do masters and PhD and work in the academic part. I quite miss this part, so I'm trying to catch up, to learn as much as I can. And also other challenge thing is that I have to research with a very specific goal, and I cannot distract or lose my time in researching more than I need to research. This applied research is, it's good to do applied research, but is probably for those we are more we usually go and research, and we can go to paper and start digging in, or we can go to a rabbit hole. We have not much time to spend or doing research that is not fully applied into our work. I need to stick to company goals, which is not that difficult, but also it means that I cannot waste time in other things. I have to overcome the academic side environment and be more in contact with people. This means that when you work in a lab, probably a few of you feel identified. You probably be a little bit more lonely, or it's you. And even if you have teammates in your laboratory, it's not the same that having a team that relies on you entirely the whole time. And also another challenge is like, it is not 100% research environment. We do a lot of research, and work is totally dependable of the manufacturing side. The perks of this job is that I get to work in an even environment. I do a lot of office job, but I go to the manufacturing side, and also I can work in the lab. So when I get bored of one thing, I can move to the next, if you want to see it that way. I get to practice the engineering knowledge, like I say in the challenge. Applied research also can be a perk sometimes, because you exactly know what you're looking for or what you look for. I get my own laboratory that I'm responsible for, so I can set the laboratory not as I please, but as I think it will be the best. I work in a multicultural environment. It is great because we get to exchange a lot with our coworkers around the world, and we do a lot of networking with everyone in Zeiss. Everyone is very friendly. Everyone is very open to help. And I work in new field with environmental purpose. So the environmental part is very important for me, and I think my company is trying to pursue this, and I highly appreciate it. For me, that will be everything today. I will step to see if any of you have any comment. I appreciate your time in this quite fast talk, and I hope I have the opportunity other day to talk about other research. But in the meantime, thank you so much for being here with me today. And if you want to reach me out, I'm linking as Estephany Santiago, my maiden name. And also you can contact me in my personal email, stephanysantiago@gmail.com. Or if you want to go ahead and do more a corporate thing, you can reach me out on my corporate email, stephany.santiago@zeiss.com. Thank you so much.
Awesome. Thank you so much, Dr. Santiago. So now